Okay, section 1.1 is going to start our discussion on functions and their graphs. Section 1.1 deals more with looking at graphs than anything else. And the first part of section 1.1 is does the point lie on the graph? And you should be able to algebraically show whether a point lies on a graph. So y equals x squared plus 3x plus 2 is going to be our example. We're going to check 2 points. We're going to check the point 2, 0, and we're going to check the point negative 2, 8. So ordered pairs, it's an xy pair, so we need to think about the fact that 2, 0, 2 would be my x value, 0 would be my y value. So I'm going to go ahead and put 0 where y is, equals x squared, well my x value is 2, so 2 squared, plus 3 times 2 plus 2. Then I'm going to go ahead and simplify. 0 is supposed to equal 4 plus 6 plus 2, and right there should be ringing a bell. 0 definitely does not equal 12. This is not true. So no point is not on the graph. Negative 2, 8. Again, now might be a good time for you to pause the video, try this problem before I go through it. It's exactly like the previous example, so it's a good time for you to try it on your own. So again, this is an xy pair. So we have 8 is equal to negative 2 squared plus 3 times negative 2 plus 2. Negative 2 squared is 4, plus negative 3, or 3 times negative 2 would be minus 6 plus 2. 4 minus 6, negative 2 plus 2 is 0, so we have 8 equals 0. Again, we would say not true. So then we would say the point is not on the graph. So fairly easy, given an xy pair, you can substitute your x and y values into your equation to see if it is on the graph. Next thing you're going to do in this section would be to sketch a graph. Okay, for this particular section, when you are sketching a graph, what they're wanting you to do is to create a table. So we're just going to create a table of values. So fairly simple example, y equals 3 over 2x minus 1. So I typically like to pick some negative and some positive values so that you can see where things look not only at the origin but to the right and to the left. So here's my x values, y values. I will typically always pick negative 1 or negative 2, negative 1, 0, 1, and 2. So to sketch a graph, I've got to create a table. So then I'd have some xy pairs to plot. So if negative 2 is my x value, negative 2 would go up here. So we've got 3 halves times negative 2 minus 1. That would be a negative 3 minus 1 is negative 4. And I could continue to fill these in. So negative 1 in there, negative 3 halves, minus 1 would give me negative 5 halves, negative 1, 1 half, or 2. This last part, well, 2 more things about this section, but the next piece, and then I could go ahead and plot these, which is what you're going to be expected to do on your assignment. But I am assuming that all of you can plot the point -2, -4. So I'm not going to take the time to go through that example. Next feature that's important with graphs would be finding the x and y intercepts. Okay, this is on page 107. Okay, simple rule. If you want to find the x-intercepts, you set y equal to 0. And you solve for x. Okay. To find the y-intercepts, you set x equal to 0 and you solve for y. So let's do an example. I'll give you the problem. You might want to see if you can do this. This is something you've already done before, so now might be a good time, once I get my example problem written, pause the video, see if you can do this. A lot of this should be review for you guys. So we're going to find both the x and y intercepts of that cubic function. Again, if you haven't paused the video, see if you can pause the video and figure out, let's find the x-intercepts to start. So to find the x-intercepts, I set y equal to 0, and I solve for x. Well, how am I going to solve that for x? Well, it's a cubic. I think I can probably factor it, seeing that there is a greatest common factor of x between those two things, which would leave me with x squared minus 4. If there is an x out front, then automatically one of my x-intercepts is going to be 0, because if I solved that, I'd have x equals 0 to take care of just this x. Now what about x squared minus 4? How do I solve that? And that's equal to 0. You could factor, which is probably what I would do, or you could add 4, and then take the square root of both sides. So you'd have x is equal to positive and -2. Don't forget both. So all of our x-intercepts are points, so they should be 0, 0. Remember, because x was equal to 0 and we set y equal to 0. Then we should have 2, 0, and -2, 0. All right, let's find the y-intercepts. Again, if you haven't paused, pause now and see if you can figure out the y-intercepts. To find the y-intercepts, I set x equal to 0 and solve. And a lot of people, this one is sometimes easier. So 0 cubed minus 4 times 0. Y is equal to 0. So my y-intercept is 0, 0. So that would be finding x and y-intercepts. It all goes back, no matter what type of function you have. If you want to find the x-intercepts, you set y equal to 0 and solve. If you want to find the y-intercepts, you set x equal to 0 and solve. Okay, very last thing that we're going to talk about in this section is a graph's symmetry? Okay, and you have three possibilities. You can be symmetrical to the y-axis, x-axis, or the origin. So maybe be thinking about, there's one specific type of function that I'm thinking about that's symmetrical, that can be symmetrical to the y-axis most frequently. And to me, that would be maybe a parabola that had its vertex on the y-axis. So that's what we're talking about. Can you fold the graph over and it will go ahead and be an exact copy if you fold it over either the y-axis, the x-axis, or the origin. So how do I figure that out? Well, if you know that there is a point xy on your graph, in order to be symmetrical to the y-axis, the point negative or opposite x, comma y must be on the graph. In order to be symmetrical to the x-axis, the point x opposite of y must be on the graph. And in order to be symmetrical to the origin, the point opposite of x, opposite of y must be on the graph. So at the very beginning of this video, I talked about how do I determine if a point is on a graph. Well, we know how to do that. So now if I could figure out a point that is on the graph, then I could go ahead and test these three different scenarios to see if it is symmetrical either by the x-axis, y-axis, or the origin. So what I'm going to do is I'm going to give you an example, and instead of solving it, I want you to try this at home. So test for the symmetry. Is this particular graph symmetrical about the x-axis, y-axis, or the origin? And I want you to come to class tomorrow with your solution. So our example is going to be x is equal to y squared minus 4. So I want you to test for the symmetry. So remember, you have to know a point on your graph for sure. So the first thing you have to do is find a point that's on this graph. Okay. Next thing, test if it's with the y-axis, x-axis, or the origin. And I want you to try that on your own tonight. Come to class tomorrow with your answer.